You don't want to extrude, you want to offset. See, extrude, you have to pick curves, it says like curve. You trying to make the inside, the smaller one, yeah, that's offset.
Oh, yeah,
For the surface.
I didn't even notice it.
Offset. That's the one you want. See how it says select face, so now you can pick. Okay, so we're gonna do what we're calling exercise 2. Exercise 2 is actually just one project for the whole number 2. You know, exercise 1 had 3 different projects, A, B, and C. This one's all one. Here's the D2L page. It's just called fuel filler door creation. So what we've done up to this point is we made the body side. I'll open mine just to show you what we did. You don't really need it in here, but we made that thing, right? And everything about this was based on those original inputs from the Class A surface. We had a slab surface we started with. Then we had, we made those kind of cylindrical shapes. There was 2 of them. There was a center line right down the middle where that opening is. The outer cylinder was basically what we started with to figure out where, you know, this inside wall was. This is we're calling this the fuel door opening, right? But now we're gonna make the fuel door, well, that fits inside here. So the other cylinder we made, that the Class A people made, we made it as the Class A people. It's a little bit smaller, that's what's gonna tell us how wide the door is. So the door is obviously smaller than the opening, right? So there would be a little gap between the edge of this and the door, and you'll see when we're done. Now in my instructions, I never have us bring the door together with the body side. But you can do it, you know, once you get it done. I'll probably do it at the end too. Once you get it done, you can open up the body side like this, and then temporarily add the door, the fuel filler door, to this assembly. It should show up right there. And just see how it fits inside there. I just thought of something else while I'm doing this. You might notice when I think I did talk about this a little bit before, when I just open up this assembly, and it looks like it's kind of chopped up, right? Or faceted, it's choppy. Remember, part of that is because it didn't really fully load the parts. So that, you know, and I know it's not fully loaded because over here in the read-only column, it's got a dashed square. Just making it the work part, if you double click on it, that fully loads it, and that actually made it sharper, okay? But something I don't think I said before was, even at that, sometimes, you know, if you get zoomed in close enough, it still starts to look faceted. There is a way, it's not bad because we don't have huge assemblies here, but if you're dealing with huge assemblies, this would take up a lot of math. But you can go to File, Preferences. I'm just showing you something that's nothing really to do with the project, but just how you can visualize stuff. If you go to File, Preferences, Visualization, I'm in this Performance area, and there's an Advanced. See here it says Shaded Views. What kind of resolution do you want? And it's possible to have it set to Coarse, which looks really ugly. You could also set it, mine was set to Standard, which looks a little bit better. This is something, I used to talk about this in other classes. It cracks me up how. Then they got one called Fine. And then I'm assuming over the years, as the technology got better, they said, well, we had one called Fine. We have a better one now. Let's call it Extra Fine. So they have that one. And then they even got a better one. Let's call it Ultra Fine. So I think they probably kept getting better over the years with technology. So that's why there's so many choices. But the idea is, if you set it to Ultra Fine, then you can zoom in a lot closer and it still doesn't look too faceted. It's all visual. It has nothing to do with the quality of the parts. But I just wanted to mention, I'll do it again real fast. File, Preferences, Visualization, and there's a little tree over here on the left. It's in the Performance area. You can find it just clicking around, but it's accuracy, all right? Now, again, there's always trade-offs. This is not a lot of data. If you had an assembly with thousands of parts and a bunch of faces and you try to zoom in, that might slow down the performance a little bit if you try to make it too ultra fine, right? But the stuff we're working with, ultra fine works good. It works just fine. So case that bothers you, that it looks a little bit faceted, sometimes you can try that. Anyway, I'm gonna actually close that, because that's not what we're working with today. Today, we're gonna work with the fuel door. Let me see if I got an old one. Show you what it looks like when it's done. Probably not in winter 24. Oh, I got the same name opened up, so let me close the one I made. I think I saved this. Let me save that one. I already made this in preparation for my demo. I'll close that, and then I'll open the one that should be done. So, and see the funny thing, it looks like it's faceted again, right? Well, that's because it's not active. It's not fully loaded. If I double click, now it fully loads it. Also shows some other things. But that's what we're making today. We're gonna make the whole thing today. A lot of little kind of confusing steps, but what's confusing about it is we're making lots of little surfaces and in-between surfaces. We're gonna offset this and then trim it back, and it's hard to visualize just by looking at my instructions. I know what I'm trying to show you when I look at my instructions, but you know, for you to look at it, you might be thinking a little different than my brain does, so you might be thinking, I'm not sure. So that's why it's good to name everything the way I tell you to, because I'll tell you to name, select this thing called oversized surface for the fuel door, right? And if you see a whole bunch of surfaces out there, it's kind of hard to know which one to pick. The name will give you the right one, all right? So name things the way it tells you to in the instructions. But we're making this thing, it is really almost just a circle, but the shape of that circle, it's not flat, it's slightly contoured. Because the original surface, I don't know if you can see any curvature in it, I'm exaggerating, but it's curving like this, because that original slab surface has some curvature in it. And this is really just an offset of that original slab surface. So we're gonna make that. We're also gonna have this finger pull area right there. I'm trying to show it to you before, because in the instructions, if you're looking at the Word document, you can't rotate the screen on the Word document, so I'm trying to show you here. So that thing right there is the finger pull, and you still will see these. I go to the gas station sometimes and I see an old van, not that old, but an old minivan, and they still have this kind of a door on it. Mine now, the newer ones, it doesn't have the finger pull, you just push on, it's got that little magnetic or
There is
clicky.
nothing wrong with that kind of door.
Oh, I know. I'm just saying, I guess I'm saying you still will see some of these, but that's what it's gonna look like when it's done, right? And not to get too far ahead of it, but that little shape right there, that's actually a little piece of a cylinder. If I look at it from here, there's gonna be a cylinder that we're gonna draw, or we're gonna create a cylinder right there. And then, so we're gonna make this big slab over here, we're gonna make a cylinder over there, and then we're gonna put this guy in between them. That's a blend type of surface. And then the thing is, this is where it gets a little tricky. I guess I can show you in this picture, if I do it right. There's two sides of this. We are only designing one side of material. So it isn't very realistic. There's no thickness, a piece of metal has thickness. This doesn't have any thickness, it's all surface. But it comes up the front, it goes across the top, and then it comes down a little bit on the other side. That's called the hem flange right there. So this is still the design side. In real life, we would take this part, we would add thickness to it. Let me just do it. Maybe this will make it easier to grasp what I'm trying to show you. Where did they move that guy? They keep moving stuff around. Oh, I gotta scroll down. No, it's not on there. I'm looking for my thicken. Do you see it on there? You might see it before I do. I just want to show you real fast. What we would do in real life, even if it's a real thin piece of metal. Really? Did they change the name of it? No, it's not. It's gotta be thick. Why I didn't bring it up. But I would add a thickness to it of, it's not even a millimeter, so I think it's like 0.61. Okay, so now I'm actually turning it into a solid. See, so it's actually got thickness. You can see the bottom of the hem flange. Let me just hit OK. That's right, so you see what I mean? There's a little thickness to it on the bottom. That's a piece of metal right there. There's the edge of the piece of metal. We're not really designing with thickness. We're designing the inside of that. So that's, again, that's what makes it a little bit tricky, because they're real close to each other. That wall, oops, I should have stayed on there with my cursor. The two walls are really close to each other, so I guess what I'm saying is it's hard to tell that that's a hem flange. And see how you can sort of see behind it there? You can sort of see inside the part if I rotate it like that. Anyway, that whole hem flange surface right there, that's an offset of this side. So that's what we're gonna make, right? I took a lot of time talking about that, but I haven't even started the exercise yet. I guess I should just close that. So I already have the first couple of steps done. I put them in my folder called Winter 24. I got a new folder called Fuel Door, and I got an Assembly Fuel Door. So I don't have to go through this because it's not new, right? So you make an assembly, you add 3 components to it, right? The assembly's called Assembly Fuel Filler Door. The parts are inputs fuel filler door, and outputs. So, same philosophy we've been doing for everything else, right? We are gonna use the same inputs we've been using. I already said that though. The main shape of the door is based on that original slab. The location of the door is based on where the fuel door, cut line fuel door is located. That's why we made it a long time ago as the Class A people. That tells the fuel door person, so today we're the fuel door people, that tells them where the outside perimeter of the door is. And there's also that center line, right? So let me just activate these, just because if I created them, they would be active. But because I closed it and opened it again, they're not active right now. So we got this assembly, right? It also says, once you create this, actually, I'll do it in the same order you're gonna do it. I ultimately already went into the inputs and I added a feature group called input geometry. So you're gonna do that. You're gonna do the same thing in the fuel filler door. And then you're gonna create some other feature groups. I already did that too. I don't need to demo that. It takes more time. The demos are already long enough, right? So there's a few things I did before I started my demo. But now I'm gonna go borrow that information. My inputs fuel filler door is where I'm gonna grab stuff from other assemblies or other parts that I need to use for my fuel filler door. Remember that? The inputs, it's like a folder. So to go get that stuff, I need to add it to my assembly. So my top assembly fuel filler door is now the work part. I want to temporarily add a component. Okay. I want to go find that component. If I had it loaded in my session right now, I would see it under loaded parts, but I don't. So I can go down here and it says open. It's kind of like a browse window. I have to go find my outputs Class A. So where do I got that? I got it in another folder here called Class A Assembly. There's my outputs. And remember, when you're adding components, and I don't give you all the steps anymore. It just says use add component to add the outputs Class A. It does actually. It says use absolute work part for the assembly location down there. Because if you don't, it's going to tell you, well, where do you want to line it up in your assembly? If you have it on absolute, it automatically lines it up. And remember, there's a reference set. In other words, a filter, when you add this outputs folder with all that geometry that the Class A people made, if you want to see that little center line, I know everybody keeps having a problem with this. You're saying, I see the part, but I can't see that little line. Remember, there's a filter. It's a reference set. And if the model filter is the one you're using, it only shows faces. If you want to see wireframe, you have to have it on the entire part. So if I hit OK, it added this. A lot of times you're zoomed in so you don't see it. So remember, you can do the fit, and then you'll see that. That's my new, not my new, that's my old outputs Class A. And I do see that center line because I told it, when you add this part to my assembly, bring it in with the reference set called entire part. If you didn't see that line, I know I've said this 10 times, I'm gonna say it again. Even after the fact, you can right click, go to the reference sets, which are filters. Yours might be set to model where you don't see wireframe. We don't want model, we want entire part that shows us wireframe. Okay, even though that's overlaid, it's weird how it's not, it's usually dim because I'm not actively in it. No, I guess, no, because I'm not in, if I'm in another part, like now I'm gonna go to inputs. When you're in one part and there's another part that you can see the other external part is they call it de-emphasized like that. If you're at the top of the level of the assembly, then everything's kind of emphasized. So after all that, We would now go into inputs, we would go create a feature group called input geometry, I already have it. I do need to make it active though, because what I wanna create needs to go in it. And here's something we've been doing many times. Go to the wave geometry linker. We can do it in any order we want. I tell you to do the curve first, so you go to composite curve. Pick that guy, and remember I keep telling you this, but I wanna remind you, why do we spend all that time naming everything? Like sheet bodies and the underlying lines? Because if you go here right now, there's the name, center line of fuel door open. If I didn't name that, it would say, single curve of something in the outputs class A surface. It wouldn't tell you it was the center line. So that's why we name it. It makes makes life easier down the road, like when you're doing this kind of stuff, right? It just says make sure it's associative. Probably a good idea to hide the original. Hit OK, or actually I'm just gonna hit apply. I just added one link. Then we're gonna do the surfaces, or faces. So we go to face. I'm sorry, no, not face. We're doing bodies. We could do faces, but we're gonna do bodies. I'm looking at I don't remember talking about the face chain one, but that's because we're doing entire body, sheet bodies in this case, all right? And in the instructions, let's quickly show you, it says, go to the fuel door main slab, the fuel door cut line fuel door, and the body side main slab. So, first one it mentions is fuel door main slab. How do I know which is which? Well, if you hover over the right thing, there's the name, fuel door main slab. I only see it because I took the time to name it earlier. And I'm gonna say this again, I know I've said it before. We aren't really gonna use that one. We've had that one there the whole time, the fuel door main slab. It's a yellow surface that looks like it would be the fuel door, but we actually don't use that. We're gonna take the main body, sheet body, and trim it. So I kept saying I'm gonna change my instructions and take that one out of the equation, but I never did. Anyway, that's the first one. The second one it says is the fuel door, cut line fuel door. Remember, that's the 2 cylinders I was talking about. So that cylinder, I don't need that one. That was the one we used to tell us what the opening was in the body side. We're not doing the body side anymore. We're done with that one. This is the one for the fuel door. So that's the one I want. Fuel door, cut line, fuel door. I hesitated. It's okay. Make sure I see it in the list. It's the inside one. I'll apply that. That adds it to my list. And then the last one is the body side main slab. Pretty obvious, but the name helps. And then I'll hit OK. So I made the same links we always do. I'm actually gonna hide that fuel door main slab right now. It was sort of hidden anyway, it was yellow, but we're not gonna use it. Okay. Then we're going to, then we gotta get rid of we don't need the outputs anymore, so I go back to my assembly. Here's the outputs we temporarily brought in. I'm just gonna delete it from the assembly. Remember, that does not delete it from wherever I have it stored. It deletes it from my assembly. That always gives us a message about links being broken. That's okay, that's a normal way of working. That just means if I go right back where it was, where I made those links, now it says, well, I don't see that outputs anymore. I don't see the linked parts. It's okay. That's how you're normally working. You temporarily see the links, make links to them, and then you get rid of the links for now, get rid of the link geometry and external geometry, and you just work with this stuff for now. It's not gonna change, it is there. I can use that as a curve, I can use that as a face, and that as a face, or a body. So it's normal to see broken links. I mentioned that in my instructions, okay? Then we go to input geometry in the fuel filler door. So this is the inputs file. Now we're gonna start doing the work. Okay, it's a fuel filler door. And it says, create a feature group called input geometry. A little bit later on, it's gonna say, create a feature group called form and trim and final. I already did it, just so you don't have to watch me do it, but here's input geometry in my working file. This is the working file called fuel filler door. In the inputs, in this one, I need links to my inputs part. So I can see them. Of course, right now I see them, but I don't see, something's missing there. You know what's missing? That center line. Well, I think I just told you this. What do you do if you don't see a center line? I know it's supposed to be in inputs, but I don't see the center line. Must be the filter. Right click, reference that. See, it's on model. If I make an entire part, then I see it. I'm still in my fuel door, but I want to make links to those. So we're doing the same thing, and again, it seems like overkill, but it's a common way of working, it's a common, methodology. Have one folder with all your inputs from all over the place. Then in your working folder, you borrow the inputs that you need for this particular part. So that's what I'm doing now, and I'll do this one really fast, cause I just did it. It even says just repeat the process. So composite curve, pick that, and go to body. Pick the other ones. Pick that one. And in fact, I'm not even gonna pick the fuel door cut line, fuel door, the fuel door main slab. I tell you to, but you don't have to. You get it, is that yellow one? Okay, it's kinda hard to see it. It's in there somewhere, but it's hard to see it. And then actually, I don't know if I tell you to do this, but I'm gonna go here. I don't need to see the inputs. I'm in my working part. I still see my inputs. Just to be safe, I'm gonna hide them with that red check mark. Right, I mean, here's the working file. If you show the inputs, why are they not showing? They should be showing. Yeah, not show. Oh, maybe because when I said hide the original, that hides them inside their own file. Anyway, I'm gonna hide the inputs, show the fuel filler, that's what we're working on, it's the work part. Okay. So now, to make just like before, when we made the body side, the data that we were given by the Class A people, this stuff, that's the design, or the thickness side, right? We're making the design side, so we're gonna have to offset everything, okay? So we're gonna offset it by the material thickness. Just so happens, excuse me, the fuel door has a different thickness than the body side main slab. Body side main slab was 0.7, when the fuel door is a little thinner, it's 0.61. So a little more than a half a mil, and these are real numbers, so sheet metal for the vehicles are, sometimes it's pretty thin stuff. Well, we're gonna make a parameter, an expression, because we're gonna use that number a lot. We're gonna offset things by the material thickness. So remember, you go to Tools, Expressions, right here. It tells you, right, by default, it wants you to create a new one. There's a field there to type in a name. We're gonna call it fuel door, and there's no spaces, so I use an underscore. Fuel door, material, I didn't even use an underscore there, should have. Fuel door material thickness, yeah. And it's, so the formula is simply gonna be, type in a number, 0.61. Oh, it should be length. It defaults to length. I always forget to say it because it defaults to length. Almost always we're making length anyway, but you should check that before you create it. Make sure it's set to length. Everything's in millimeters, by the way. So there's our user expression now that we can use. Every time we do an offset to get the material thickness, we can use that. Okay. And in fact, we're gonna do that now. We're gonna take the main slab, because as I said, we're using that shape, the shape of this guy, to make the door. But it's gonna be an offset of that based on the material thickness. So in the surface tab, you go to offset. This is not new either, so I can go through this pretty quickly. I like to set that the body faces, you should, unless otherwise told. Offset that by the fuel door material thickness. Remember, lots of ways to do it. You can go to formula, go to the expressions panel and grab it, or remember, this is a little bit easier. This is after you get more confident, you start doing it this way. If you know the name of it, I know it started with an F. FU, there it is. FU is, that narrowed it down to fuel door material thickness. Okay. I hit enter, it doesn't change the number yet. You hit preview sometimes and you undo it. Sometimes if you preview it and then undo the preview, then you finally see the number. Important to note, it's gray now and there's an equal sign, meaning that I can't just type over that now. It's tied to something. Which is fine, and we do need to go inboard. I keep saying inboard. That's in the positive Y direction. I want to remind you, keep looking at this thing down here. It's called the view triad. Positive Y is obviously that way, so my offset's going that way. You can see the blue cone. Hit OK. We're going to name that, of course, main slab design side. Also, it tells you to do this too. You know what I'm thinking of it. I didn't put that in the form feature group. I put that in this one. I should have made the form feature group active. No, I don't know if I can drag it. You know, if it's active, you can't drag things in there. So what I have to do is, I'll update to the end here, I'll make the last feature current. I should have made this active before I made that surface, offset surface. But I can do it after the fact. Now it's in there, it should be in the form. And I do need to be active because the next few things I'm gonna make is gonna go in there. But this we're gonna rename to main slab design side. I'm renaming, what? I'm renaming the feature. Right? We talked about this quite a bit. And while I'm at it, I'm gonna copy that. You know what else we're gonna do, right? I'm gonna do a Control C, you don't see it, but I just did a copy. So I got that copied. Oh, by the way, now there's two surfaces out here. There's the original main slab, then there's a main slab design side. I don't wanna get confused. We're gonna be working with the new one we just made, so hide the link body called body side main slab. That way, the only one you see now is the design side of that slab. And yes, like we've done many times now, I wanna rename the underlying sheet body. How do you do that? A few different ways. The way I try to get you to do a lot is hover over it, wait for the dots. That way you can pick everything that's really there, which is the feature, but also the sheet body that makes up the feature. There it is. Rename it. I'm sorry, go to properties. And because I did a copy, I should be able to do a paste. Got the same name. We always want to turn that on. Apply to the work part, which doesn't really affect our process, but it's a good thing to do. And again, as a reminder, I typed it in, it was like this. It was upper and lowercase, but if you now go over that, sheet body always turns the name to uppercase. So the sheet body itself, the underlying sheet body, has its own name now. It's the same name as the feature, which I don't understand why you would never do it the same name as the feature. I guess you could. Anyway, so now to continue working, I'm gonna make an intersection point. Well, let me jump ahead a little bit, all right? That I said we're gonna make a cylinder. I like to show you this just so you can get a clue of why we're doing these next few steps. Ultimately, I'm trying to make this tube right here. That tube, a little piece of that tube is gonna be that finger pull I keep talking about. So most of the tube's gonna go away, but there's a little bit of it right about here that's gonna be that finger pull piece. This little piece right here, this is that little tube. Okay, so we're making that tube. That tube's gonna be built along some center line. Okay, so we'll go into, there's the tube. The center line's right down the middle of it. The center line is at an angle to, essentially, it's at an angle, 30-degree angle to the direction of the main surface, okay? So we're gonna have to create something that sort of gives us the direction of the main surface so that we can put a line at an angle to it, and actually we're offsetting it. Okay, so that center line is somehow related, it's 30 degrees to something, it's somehow related to something that's going in the same direction as the surface, right? So that direction of the surface, that's what we're building in the next couple of steps. Okay, it still won't seem like it until we do a couple of steps. So when I say the direction of the surface, remember, I don't know, well, we didn't do it in this class, I don't think, but in NX1 class or NX2 class, we talked about isoperimetric curves, which is a curve that represents one of the two main directions of a surface. So this surface is, there's a U direction and a V direction. I don't know which is which, but, right, there's equations for this way and an equation for that way. And there's an infinite number of curves going this way and an infinite number of curves going that way, each in those different equations. Well, I want one that's right where the middle of the line meets that surface, right where this line meets the surface. I want a line on this surface that's going in that direction. Well, all right, so let me just do it. So we start out this way. I'm gonna do an intersection. I'm gonna go Home tab, actually Curve tab, go to the Point command, do an intersection. Okay, remember when you're doing an intersection, the second thing you pick has to be a curve. So I'm gonna intersect the curve in the face, so I gotta pick the face first. And then you have to automatically go there. You have to manually go to that next field. There's my point. Now that's obviously right in that surface, right? I'm gonna now make an isoperimetric curve. That's a curve that follows the shape of this surface. That was in the Curve tab, the Derive button, or the More Gallery, the Derive group, the More Gallery, isoperimetric curve. okay? I tell you to do the U direction, so that, technically, that means the U direction is going up and down. But it says select the face, I'll pick the face. It actually does show me a little symbols there, there's a U arrow and a V arrow. And you might think, well, the U arrow is pointing this way, so why is the curve going that way? Remember, the U direction means, give me all the curves that are, you know, if I pile them up on each other, they're going up the surface. That's why that's called the U direction, even when the curve's going that way. I don't wanna do a uniform number of curves, I wanna do one curve through a point that I choose. And that's why we made that point, so I'll make sure it says point, existing point, and there's that curve, okay? So that's, again, that's gonna help us to come up with that center line for that tube. The problem is, that's a curve, that's not a line, because that surface has got a little bit of contour to it. It's not really straight. It's kinda hard to tell, but I'm exaggerating, but it curves this way a little, so that's not a line. So I can't make an angle to that, because that's, you know, to make an angle to something, it's gotta be a line. So there's a couple of steps that seem a little flaky here. It's just to get us, basically what I want is I want to take this curve, and I wanna draw a line right here, starting right here where that finger tab's supposed to kinda start, right there. I wanna draw a line that's actually in the same direction as this curve right here. Because that curve obviously changes its direction. Whatever the direction is right there, I need a line. Because ultimately I need a line to make the center line of my tube. I don't know if that made a whole lot of sense, but we need a line that's using the direction of that curve. But I want it right where this line, or where this curve meets this guy. So guess what, I gotta make another point. Okay, another intersection point. I'm gonna intersect that thing with that isoparametric curve I just made. Now it says multiple intersections found because it intersects it here and here. It's previewing one of them, okay? Happens to be the correct one. But if it was over on this side, it would look like this. See how it's on that side? If you click on the curve, you can move it to either side. Oops, I accidentally picked something, I don't know what I did, let me start over. I clicked on something other than what I should have. If it's the right one right off the bat, you can just hit okay. Let me do it again. I want to intersect that surface with that curve. If that's the one you want, just hit okay. If it's over here, pick the curve on this side and you see that little sphere show up there. So that's the correct one. I should just be able to hit okay. And you see it put a little point right there. Okay. Now this too is going to seem like, oh, I got to name that. Actually, I don't know if I was supposed to name it. Yeah, that point, that first point. Oh no, I didn't name that, sorry. I'm naming, actually the next thing I'm naming is that point I just made. So this point finger pull setup. Now we're not gonna use these down the road anywhere. So I don't make you go through the motions and rename the underlying point, because there is an underlying point even for that. Point finger pull setup. A long name for a little point. Okay. Now here again, this is. I'll try to explain it. It's hard to make a line that's tangent to this curve, starting at that point. It's a lot easier if you pick the end point of a curve. This curve now continues all the way beyond it. I want to have a curve that has its end point right where that little point is. So I have you do this. I have you do a trim curve. If this doesn't really make a whole lot of sense why we're doing these little extra steps here, don't worry about that too much. This is just a method to, this method's been used for years to kind of come up with a finger pull, right? But I want to trim this curve right where it meets that point. Okay, I picked an actual point that I just created a minute ago. Okay, remember that with trim curve, you can see it doesn't automatically give you a preview, but if you go to select region, it shows you, where that thing is getting trimmed. It shows you one side or the other. And if it's set to keep, that means it's going to keep the one that highlights. If it's set to discard, that means it's going to discard the one that highlights. Well, I want to keep that one. So make sure the one that's orange, make sure the one that you want over here, if it's orange, you want to keep it. If this side's orange, you want to discard it because you want to keep that side. All right? You see it trimmed it. Okay, trim my isoparametric curve. And here's another thing, I don't know if I tell you, to hide the point, Yeah, it does say, hide the finger point, point finger pull setup, that little point right there. Only because to do this next step, it's easier to start with an end point than it is with an actual real point. I'll show you what I mean. If I hide that point, this curve does end right there, because I just trimmed it. Double check and see. I was supposed to call this trimmed isoparameter. And I want to feel your pain, so I'm going to name everything too. Trimmed isoparameter. Isoparameter. Yeah, it just looks like I spelled it wrong in the instructions, but I didn't. That's right. Okay. So I hit the point. Now I'm going to make a line. Okay. And this is why we did those couple extra steps, where I made a point and then I trimmed that curve. Because I want to make a line in the start object. It's a lot easier to pick an end point right there for some reason than to pick a real point. So see that little symbol, and I tell you this in the instructions. See, there's a little window that pops up. It says line of trim isoparameter, but there's a little symbol in that window that shows, it kind of looks like a matchstick. That means you are picking the end point, and that is what I want, right? So I'm gonna go off and go back on so I don't do the 3 dots. So I picked the end point. I want it to be tangent to something. I'm gonna pick that curve. Doesn't matter where I pick the curve. Okay, so I'm making a straight line that happens to be in the direction of the curve where that endpoint is. And the length is not real critical, but we're gonna do a -50 and a 50. You want it to be big enough that we can use it, and then we can, it's overbuilt for what we really need, but I don't want it too small, I don't want it too big. So 50 and 50. So what I just made right there is a little line. I know it's hard to see it. That's a real line, it's a straight line. It's on this, it's starting right at the end of that curve, but that's a curve, and that's a line. So I want to make essentially a parallel of that line, or an angle of that line on a plane. Okay. In fact, I need to make a plane too, so I need to pick lines. We're going to make a plane through lines. That's not necessarily planar, so to make a plane through 2 lines, you needed a line. So that's another reason why I made a line. And in fact, I'm going to hide this guy, that trimmed isoparameter we made. The line I just made, did I name that? Nope, I just have it as a line. Now we're going to make another line, create a second line. Oh, I'm sorry, yeah, I am going to make a plane, because you know I said I'm going to make a 30-degree angle to this guy, and that's going to be the center line of that tube that's going to be for a finger pull. Well, I'm also going to have, when you say 30 degrees to a line, it's got to be on some support, on some plane. So we're also going to make a plane right here. And the way I do it, in a nutshell, is, let me show that finger point again. This could be done a few different ways. I'm going to make another line, okay, starting at that point. I'll wait for the 3 dots, and I can pick existing point. Then we're going to go normal, and we're going to go normal to the main slab. This too will be -50 and 50. So ultimately, I'm trying to create a plane based on some lines. Based on some lines that are kind of tied to my surface, and to the, basically tied to the surface. So what I really have right here is this line. This line is exactly perpendicular to my main slab surface. That line is exactly in the same direction as the main slab surface at that point. So both of those lines are intrinsically tied to the surface, right? The direction of the surface, and that's kind of important. And by the way, every one of ours is going to be a little slightly different, because all this stuff goes back to that circle we made, right? So our point might be in a different spot than somebody else's. Because that first circle we all drew with 3 points way in the beginning, they're all slightly different. Everybody's just slightly different. I'm going to hide the finger point finger pull setup again. I'm going to put a plane now through 2 lines. Those 2 lines that are, again, related to my surface. Just leave it right there, that's fine, the size of it, okay? Now I got a nice flat location that I can take this line, and yes, it's a line. I think I'm gonna, I don't tell you to do this, but in instructions it kind of has this done. If you go to edit object display, and say, let me make that, why is it picking everything? Let me pick this first, let me pick just that surface, the sheet body. Pick the sheet body and I go to edit objects. But you don't have to do this, I'm just gonna make it easier. I'll make it translucent so you can kind of see through it, like so. So you can see my lines and you can still see the slab a little bit, alright? So I got the plane, we're gonna make a line now in the direction of that finger pole cylinder I keep talking about. It's gonna be 30 degrees to that line, so we're gonna go line. Okay. I guess I should have left the point finger pole set up because I'm using it again. Okay, I'm gonna say start it at that point. But this time we're gonna go at an angle to something, at an angle to that first line I made. At an angle to, yeah, the tangent line we made. I wanna make sure I'm using the same one. And it's 30 degrees. Okay, that's going the wrong way. There is there a reverse on this one? Maybe there isn't a reverse on this one. Some commands have a reverse, some don't. If it's not going the right way, well, actually, you know what? I want to pick the plane. Maybe it'll flip if I pick a plane, because it doesn't necessarily pick the plane I wanted. You always want to pick your own specific plane as the support. Yeah, when you pick that plane, see how it made the 30 degrees go. Well, I don't know if you know that, but that's the way I want it to go. This way. So it's kind of coming towards us. Here's the Y vector. So that angled line is kind of pointing outward as it comes towards us, right? Of course, I don't need it to be 1,670 mils in length. We're going to do the same number we've been doing, minus 50 and 50. And I'm just going to hit OK. So there's a line. I don't think I made that one either. Nope. Okay. So there's the line which sort of represents the center of that finger pull tab, except it's shifted over. We need to shift it over. Right now we're using 15 mils. All these numbers would be, you know, stuff that we got from the specifications of where this, you know, we've done fuel doors before. That's the idea. So we know, well, we usually have it about 15 mils over, so that the finger pull itself shows up right about here. You know, this would be based on somebody's experience. So I'm going to do an offset and face of that angled line I just made on our plane, 15 mils. It's going to go to the right in this orientation, in the positive Y direction a little bit. And that's going to be the center line of the tube. I'm going to hide this one for now. I might even hide these two curves at that point. Right, so I got that line. That's going to be the center of our finger pull. We're going to make a tube. Go to surface, go to more. There's the tube command right there. Remember, the tube always uses a diameter instead of a radius. That angled and offset curve is going to be the center or the path. The diameter is going to be 60 mils, outer diameter. It's not hollow, so we're going to have an inner diameter of 0, which makes a solid. Well, it always makes a solid tube. And that's what the tube command always does. It always does make a solid. But I'm going to need this outer face to do some trimming a little bit later on. Okay, so that's a solid. It's a lot easier if we get a sheet body face on the outside of that. Oh, I'm sorry, you know what, something I should have said in here, in the settings, use single segment. That makes it a little bit smoother. I didn't even do it myself, I just read in my instructions. Oh yeah, I forgot, I should have made that single. It tells you, make it single segment, okay? Then we're gonna get, that's a solid, and I want a sheet body for just the outside of that. Okay, that's in the Home tab, in the More gallery. It's called Extract Geometry. I want to extract a face. And over here it says tangent faces. That if I pick that outside face, nothing else is tangent to it, so it will just get that one face. Actually, it does say set this to single face. Because I'm only picking one, it doesn't really matter if that's single face or face chain. I'm only picking one. That one. I hit OK. And I just created down here an extracted face. It kind of looks like a solid, but if I hide the solid, which is the tube, so now I got a hollow sheet body. Okay. Of course, that we are going to need. That's finger pull surface. Finger pull surface. finger pole surface. Finger pole surface, and I'm looking in my thing, I forgot to name this too. The offset is actually gonna be named, because we're gonna reference this later. That's gonna be called center line of finger pole surface, alright? So yeah, the important things that we're gonna come back and reference, because we are gonna make a change to this towards the end. It's a lot easier to find if you have a name. Center line of finger pole surface, okay? So now I have the center line, and I've also got that kind of hollow looking tube called the finger pole surface, right? Now, let me jump ahead here again. I told you that we're gonna take the body, the main slab, the main body, right? And we're gonna turn that into just a circular shape, which is the door shape. What I'm gonna do, this next 2 steps or so, the next couple of steps, is just to sort of trim away most of it and leave us with a little bit more than we need, but a nice kind of a slab that isn't so huge that it looks like the whole main body side, all right? So it says we're gonna make an offset of this guy. We're gonna offset that guy outward. So in the surface tab, we're gonna offset it outward. More than enough. Basically, I say just go out 10 mils outward. Now, I can't type anything in there. Why is that? Because it's gray. Why is that? Because the last time I did an offset, I did a link to that expression. Remember, it remembers whatever I did last. 2 things I could do. I could reset the window, clear it out, or if you just want to clear out that field, click on the equal sign and go down here. It says make constant. That removes any links. It's just a number now that I can type right over. Okay. It's coming outward. Make sure it's coming outward. That just because, you know, we're going to see a lot of surfaces in the tree now, and just so we don't get too confused, we're going to call that one cut line oversized surface. Again, it's just so we have some slab material to work with that we're gonna have to trim back, but it's not the whole body side. We're gonna chop away a piece, right? But before I do that, let's see. You know, I'm gonna hide that inside one again. That's the one that is ultimately the exact size and shape of the door. I'm gonna hide that. This is the oversized one I just made. But then I have you do a couple of steps. Well, let me do this. We're gonna end up, that big slab we just made, we're gonna end up trimming it like this. So that's kind of overbuilt, okay? It's gonna sort of look like a Pac-Man. I'll give you the next couple steps so you know why we're doing these steps, instead of you going, okay, that's kind of funny looking, what is that for? Right, it doesn't make any sense. We're gonna have that, then we're gonna take that tube, and we're gonna trim away most of it, like I said, and all that's gonna be left is a little triangular shape like that, which is actually a piece of a cylinder. That's where your thumb or your finger actually goes. So we're gonna have those 2 pieces, and then we're gonna put a nice blend in between them so they're really smooth where they get joined up. That's in a couple steps here, like that, right? So I'm trimming up stuff, and then right now, that's what we're doing. We're trimming up to get those 2 pieces, all right? So that's this next step, which is an intersection. You go, why am I intersecting that? That actually comes to that that blend that I was talking about, all right? So you'll see why we do it. So I'm doing an intersection curve between the finger pole surface, this sheet body, and the main slab design side, which is our big slab still. Okay, looks like I pick it right. I didn't go to the next field. Finger pole, and then this guy, and it kind of looks like a little horseshoe right there. Okay, so that's where that kind of looks like a toilet paper roll, where that thing intersects the main slab. See that blue curve there? That's what we get. That's gonna help us develop that nice blend between the 2 pieces. It says, oh, and also, well, yeah, this is to help us trim everything up. It says make another tube. Here we go again with the tube. All right, surface command, more button, tube. That intersection I just made is gonna be the path. It says make a 20 mil tube. And these tools you've used, so I'm kind of going through them quickly. There's an example of if you don't do single segment, that makes it really close to matching that curve I picked, but it's also not very smooth. So that's why we say, let's just do single segment. It'll deviate slightly from the curve, but it'll be a lot smoother. I mean, it deviates 1/100 of a mil, so that's not too bad. it's still pretty close to the original shape, right? So there's a tube. Double check if I forgot to name anything. No, I guess I got everything named well. And now we're gonna do one of our friends, the trim sheet. It says hide the finger pull surface, so I don't need this guy right now. I'm gonna make that Pac-Man thing, okay? That I'm gonna trim this, with this oversized slicer here, I'm gonna cut away some stuff, but I'm gonna do it as a trim sheet. Here's where it sort of starts to come together, but you still might be going, I don't know. So I go to the surface tab, here's trim sheet. I wanna trim the main slab, this big piece, I'm gonna trim it. Now I picked it out here, you notice, right? Okay, I wanna trim it where it meets certain boundaries. One of the boundaries is the cut line oversized surface. If I left it like that, it would trim, it would put a hole in there. I wanna actually keep the inside, but it would just be circular. But I'm gonna trim it a little bit more. I keep saying this Pac-Man thing. So another boundary object is gonna be the outside of this. Okay, I'll just maybe set it to tangent faces, just pick that. So I pick the center line. I'll do that. I'll pick a center line. Pick, I undid that. This guy, and then pick the surface. Okay, that's weird how it's extending that, but it's okay. It's trimming my main slab where it meets this cylinder and these walls. Oh, I know why, because I did pick it. Yeah, second time. Anyway, it's breaking it up. Everything I picked a couple of boundary objects, and I picked the main slab. It's breaking up the main slab into a whole bunch of different regions, okay? That's what this does. That's what's kind of cool about trim sheet. You can trim one sheet with a whole bunch of different regions and pick and choose which ones you want. Then you go to the select region field. I think I tell you that yet. While that's open, go to select region. Whatever's orange is what it's gonna keep if I hit okay. Obviously I don't want that. You can unselect things. If you hold down shift, I can unselect that. And the one I wanna keep, it is on keep, is that one, and just that one. I mean, you could pick this one, you could pick that one and that one, right? All I want right now is that Pac-Man thing. That's what trim sheet lets me do. Lets me pick a target, trim it where it meets a whole bunch of things. So it divides it up into a bunch of regions, and then you gotta go and pick the regions you want and the ones you don't want. So if I hit okay, there's my trim sheet, okay? And if you hide this other stuff, it'll look like the Pac-Man shape, like I keep saying. It does say we gotta name that guy. So the trim sheet is called Trim Design Side Slab for Blend. Don't ask me why these names are long. I didn't name them originally. I guess I could change them. But, they are kind of descriptive. All right. Now we're gonna do another trim sheet, but the finger pull surface, that toilet paper tube that I keep hiding, there it is. I think I can hide oh no, I actually still want to pick that. I'm gonna trim the finger pull, the tube. Basically, I wanna make that little piece I was talking about right in here, I think. For the boundary objects, cut line oversized surface, and the last tube, yeah, that's right. So same thing I just did, trim sheet, except the one we're trimming. And where you pick, I wanna pick this tube. Where you pick it, it wants to keep that by default. So if you do pick it in here, it might help a little bit. Doesn't really matter because you can always change the one it keeps. And I'm gonna trim that where it meets. See, again, I want this shape. So it is meeting this, right where it intersects that guy. Okay, so it's gonna trim it right there, the tube. And it also meets this. So I'm gonna pick that, okay? So it's breaking up the tube into a few different regions based on those intersecting pieces. If you go to select region, it highlights what it so far thinks you wanna keep. And that happens to be the right one because that's where I clicked. If it wasn't the right one, I would unselect it. Right, you can actually use deselect all right there if you want, and then pick the right ones. That's the one I want, so I'll hit okay. And now that tube shape, let me hide this. And I'll hide the cut line oversized surface thing. That's all that's left of that tube, right? That's it. Okay. So now I've got a couple of slabs, and that of course is gonna have a name. That's gonna be called Trim Finger Pull Surface for Blend. And then we're going to do a blend here. Older versions of NX, it used to be called soft blend. CATIA, they call it a blend surface, like a connect surface. In NX, it's now another type of face blend, okay? And the type of face blend we're gonna use, it's actually a really powerful tool for Class A surfacing, stuff that's supposed to look really good. It's a commonly used command. Basically it's saying, let's put a blend in here, but we wanna make sure that blend starts out from here with exactly the same curvature as this thing, and it ends right here, along here, with the same curvature as that. Curvature versus tangency. If you just make a regular face blend, where they meet, where the ribbon meets the original supports, it's tangent, but it's not the same radius. And it's different if you visualize it. I might show you that. So anyway, I'm gonna make that face blend. But the face blend I'm gonna make is gonna require something called a spine. So that intersection I made, where'd you go? Right there. That's kind of where the center, that's running through the center where this blend is. Okay, we're gonna use that to help create it. It says, just show these three things. Okay, fine. I have that center line showing, tells you to hide it, but it doesn't really matter. So now we're gonna go to face blend. Okay. I'm gonna reset this just in case. It's a good habit. Face blend's got so many options in it. If you change one weird option, you might try to make a new one and it's got some funky thing going on because you had a weird option set. So always reset that one. But then normally we make what's called a rolling ball face blend between two faces of a certain radius, and it's a circular blend. If you cut a section through a face blend, normally it's a true circle with a whatever radius, 5 mils in this case. But what we're gonna do this time instead is, instead of automatic width, we're gonna do something called contact curve, which means it's not just gonna be some radius. The radius, you notice there's no radius on here. The radius is simply determined by, it starts here, tangent and curvature continuous, and it ends here, tangent and curvature continuous. It's gonna come up with a radius. So we pick a couple of faces. The order you pick these is kind of important. You could pick either one first. I could pick that one or that one. I tell you to pick this one first. Okay, so that's face one. And if you kind of picture it in your head, we're sort of blending up like this, kind of, right? So that arrow should actually go up, right? That was face one. I'm blending from that face, I'm gonna blend to this one. That's face two. And that arrow is going the right way. They should both kind of be going up if you're looking at it like that, okay? But then it wants me to pick contact curves. So in other words, it's saying, starting from this surface, where do you want it to start? I could actually have a curve on the surface, but I'm gonna pick, oh wait, and by the way, this is supposed to be tangent, this is supposed to be curvature continuous. I guess we'll come back to that. So whatever you picked as surface one, that should be the one you pick the contact curve from. So I picked this as surface one, so I'm gonna pick that edge. Not this edge, because that's surface two. So I'll pick that one. And then for contact curve two, that was the second surface I picked, so I gotta pick that. If you don't pick them in the right order, it crosses things over and whatnot. It's really ugly. Now it's not letting me hit OK or apply because I need to pick a spine curve. That's something I just did really quick there. I didn't explain it. It was set to tangent asymmetric, but I just changed it to curvature asymmetric. Okay. If you do it with curvature, that means it's actually a little bit more complex. It's got to do more work to make it not just smoothly blend from here to there, but to maintain this same curvature of this surface and then that curvature of that surface. And in doing that, you gotta, it's doing a lot of stuff behind the scenes. It's making a cross section in here, kind of like a circle, right? But not really a circle. It's actually making a more of a conic in here. Think of it as a conic curve, a curve that's sweeping along here. That curve has got to line up a special way, so it needs a spine. I don't know if you're gonna grasp what I'm saying, but what a spine is if I put a plane on this curve, spine, perpendicular to that curve, right here the plane would be like this, right here the plane would be like that. That's where it, behind the scenes, draws the actual shape of the cross section that's getting swept along there. That might not have meant very much to you because I could spend hours talking about spines. We're just using it here, I'll just say it like that. And I'm gonna hit OK. and there's the surface. It's a faceplate, okay? I'm gonna do this, I'm gonna hide that guy. I might even hide this guy. And in fact, I might even turn off the translucency. It's still translucent because it started out that same sheet body. So I'll wait for the sheet body. I'll pick that, I'll go to view. I just want to show you something. You're not going to do this in the instructions. I'm going to turn off the translucency here. Okay. I mean, I've got it shaded with edges. You can see the edges. If you change the shading to no edges, right? I don't know if you'll be able to tell. When I do this, sometimes it's real obvious, sometimes it's not. It just depends on the lighting. But that fact that it was curvature continuous, where this meets that and where this meets that, it makes it more smooth. It makes it harder to see where the fillet ends and where the surfaces start, where they join each other. This is just something to know. Put it in the back of your head somewhere. Curvature continuous makes it smoother so you can't see where they meet. And that is curvature continuous. So as I rotate this around, I'm looking at, I can sort of see a shadow line there, but not really, right? And on the other side, you can sort of see it. Let me just edit this and change it to just tangent. Tangent symmetric, asymmetric, okay? Tangent asymmetric, it's very subtle, but I can see the shadows better now. I can see a little bit easier where the fillet ends and where the other surfaces start. It's real subtle. You may or may not be able to see. See what I mean? You can sort of see a shadow, a little bit stronger there, a little bit stronger there. You may or may not agree with me. Maybe you don't believe it. I'm going to go back to the one that looks a little bit better. And I have to pick the spine again. So that was the intersection curves. Okay. So, well, believe it or not, it looks a little bit better this way. I mean, when you're doing Class A surfacing, that's used all the time, okay? Curvature continuous. So you got your first taste of that here in the upper body class, all right? So let's see, of course we're gonna name that guy. That face blend is, I did that, I'm jumping ahead of mine. Actually, I don't have you named that. Surprised I don't have you named that surface. Okay, anyway, that's a face blend. So that is, well, remember that's overbuilt too. We're gonna have to trim that because that's going back to that oversized cylinder we made, right? It does say when you make it. Now, I guess I should have said this when I was in face blend. Make sure in the settings, it tells you this in the instructions. If you reset it, it should do this. Make sure it's trimming the original bodies to the blend, even though they are starting right at those two bodies. But it also says sew all faces. That means it joined them together. So it made a new face blend in there, but if you hide the face blend, if you try to hide just the face blend, they all hide. And that's what you want. That's because I sewed them together. Because if you don't have it on sew together, those would be three separate pieces. They're lined up nice, but they're still three separate pieces. And now here's where we're gonna make a change. So we made that, and then it says, you know that offset face we made for the center line of the finger pole? We moved it 15 mils over. We made a line at an angle, then I offset it 15 more mils. Remember that? That was this line, I think. Yeah, right, because there was one that we made at an angle here, and then we offset it. And that became the center of the tube. You can kind of see that, it's the center of this tube. It says, you know, we made a mistake. My experience says it should have been 20, not 15. So it says change that offset to 20. And hit OK. I'm hoping I get an error. Yeah, I got an error. Sometimes, because they always, you know, every time you get a new version of NX, they make things work better and that you don't get as many errors as you used to. But I got an information window. It says cancel it if it appears. If you don't get an information window, you're fine. Well, you should be fine. But then again, look at the part, it might not look right. But it says I got some kind of error, face blend error. Okay? So what happened? What happened was, when you make changes, and ultimately this is why trim sheet is sometimes frowned upon a little bit. We made a couple of trim sheets. Sometimes after you make a trim sheet, remember when I used trim sheet to make that guy. I also used trim sheet to make that little triangular shape. Sometimes when you modify geometry earlier from a trim sheet, say after the fact, you made a trim sheet, after the fact, you go back in time, you modify something like I just did. Sometimes it changes the trim sheet regions. And I'm pretty sure that's what happened here. Right, that guy looks good, but see how there's a red X, red and white X on my trim finger pole? That was that little triangular shape. Best way to fix it is double click on it. I'm looking at it, I'm going, well, I don't see what it's trying to do. It doesn't even know what region I want. It must have moved stuff around here, and it looks like it made that intersection miss. So it probably is having a hard time figuring out what region it was. It lost the region that I picked. It says select region, but there's nothing picked. And we know it's this one, so I had to go back and pick it. Now that it's that one, that fixes everything, all right? So moving that tube a little bit caused my trim sheet to fail. And that is one of the things that, when you go work somewhere, if they have design standards and best practices, they might say, yeah, trim sheet's pretty cool, but be careful with it because it sometimes, those regions sometimes get messed up when you make modifications after that, right? I just learned that from my experience too. Trim sheets are kind of neat, they're very flexible, but they fail a lot when you make changes, so you gotta go back and fix them, all right? Actually, another thing I was supposed to do, I forgot. Before I finished it, I was also supposed to make the tube bigger, right? We made the tube with a radius of, I'm sorry, it's supposed to make it smaller. We made it at 60, it's supposed to be 56. So there's two things we actually were supposed to change. I got another error, because that might have messed it up. Yeah, I messed it up again, okay? I made another change, and guess what? My trim sheet failed. All you gotta do is double click on the one that failed. You know, sometimes it's a different region that got picked, or sometimes it lost a region like that. So that's still the same one. So both of those changes I did affected that trim sheet. And that's actually what we decided it should look like. That actually looks more like what I think I see on a minivan when I see that. Okay. Oh, is that pretty? Isn't that nice? All right. So, and it talks about what I just said. It gives you a couple of pictures to say, maybe you have to deselect things and pick new things. All right, now I'm gonna try to do this kind of fast, even though it's kind of confusing. Remember I said we got that shape. Now, if I show the fuel door, cut line fuel door, that really is telling us where the actual outer edge of the door should be. Well, actually, the material side of the outer door, right? To be honest, we're doing the design side, so we're actually gonna go inside that a little bit. All right, so let me do that. Let me make an offset. I'll get to why we're doing this if you didn't get what I just said. We're gonna offset the trim. That's where the door is supposed to go, on the outside material. Well, we're designing the inside material. So I'm gonna take that and offset it inward. Let it go for some reason. Inward, just a little bit. The fuel door material thickness. Again, I can come in here and I can start typing it. F-U-E, there it is, fuel door material thickness. Sounds good. I'll preview it and unpreview it just to make sure. Yeah, that's the name. So there it is. It's just a tiny one. I'm going to take the one the original one, the input we got, the cut line for the fuel door, and hide that. Okay, and then we are going to name this one because we're going to use that a little bit. That's the fuel door cut line design side. So the one we brought in as a link was called fuel door cut line fuel door. This is called fuel door cut line design side. This is the one we're actually going to use. I mean, we use the other one for fuel cut line design side. I forgot. There I go again, trying to type and talk at the same time. Space. Side. Okay. All right. So that is going to be the top of the fuel door. I'm going to see if I can show you this in the picture. The outer boundary of our fuel door, it's actually, it's going to be really hard to see it. But if I were to, I know I'll never be able to zoom in enough. But right along the top of this guy, you know, here's the front of it. There's going to be a little fillet, a little blend, and then right across the top, there's a little tiny flat. And then it blends down to the other side where the hem flange is, on this side. So again, coming up from the front, there's a fillet, then a little flat, and then a fillet coming back down, and then the hem flange, all right? So that thing I just made, that offset, that's gonna be the flat. Almost all of it's gonna go away, but that's gonna end up being the flat, so I'm right here, all right? So then so I named that. it doesn't say to hide that, but I'm gonna hide that for a second. I got the name there, so I'll know it. It says create an offset surface of the fuel, main fuel door, this guy. Now this is, we are gonna use this is our design side, but we're gonna make that hem that comes around the other side. That's offset by just a number that we know from our experience, 1.5 mils. So I'm gonna take this, I have it on body faces, take that. We're gonna go in the positive Y direction, or what I would call inboard, to the right in this image, okay? It is 1.5, and again, it's tied to my last thing I did, which is that expression, but I'll just get rid of that, type in 1.5, okay? So again, it's gonna come up the front, go across that little flat, and then come back down on this side. This is what we need for the hem flange. Of course, the hem flange has a big hole in it, okay? It doesn't go all the way through the part. So the next step is to put a hole in it. This is what I mean. It gets kind of confusing. Well, wait a minute. Now we're making another surface inside that first one. So it says take the fuel door cut line design side that I just made, and I have it hidden. It says offset that inward 10 mils. Why are we doing that? We're doing that to make a hole for our hem flange. So we're going to take that guy, rotate it so it's going inward. It's just a nice even number, 10 mils. So again, our experience tells us, well, on the fuel door, if you're coming from the nice, pretty front side, and you go around the top of it, and you go back to the inside, that's a hem flange. That's usually about 10 mils. There's like a 10 mil gap between the hem flange and the front of the surface, right? Front of the door. So, it is going in, yeah, so there's that. That's, of course, going to be called, that name the previous one. Yeah, I forgot the name of that one. No, I didn't. Oh yeah, no, I'm good. I wasn't supposed to name that one. I was confused by my own writing there. This is the fuel door cut line. No, this is the, sorry. No, I don't have you name this one either. I'm confused. I'm more confused than you even thought I was. Create an offset. Oh no, it does say rename it to hem flange trim surface. I have that in the middle of the instructions. That's different than what I usually do. Just to throw you guys off a little bit. So that's what we're gonna use to make a hole to show, really basically get where the bottom of the hem is, all right? And that's what we're gonna do next. Of course, we're using that guy I just said might not be the best thing to use. We're gonna do a trim sheet. We're gonna trim the hem flange slab, which I guess I didn't name it. That was that guy. No, not that guy. That was. No, I'm trimming a whole bunch of things. Reset that. That is the hem flange slab. Which I should have named hem flange slab. We're gonna trim that, we're gonna put a hole in it. We're gonna put a hole in it with this guy, the hem flange trim surface. We wanna make sure we're trimming it, so we wanna make sure there's a hole in the middle. I'll look at it from the back. If I go to select region, can you see there? It's keeping the outside, get rid of the inside. Actually, that's what I want. I want a hole in the middle of it, so I'm gonna hit okay. Now you might think, well, there's no hole. Well, I'm also showing the design side. I'm showing the front of the door, but I'm also showing the hem flange in the back. I'm gonna hide this trimming surface. Okay. All that's really left now is to make the fillets that go, like I kept saying, it's gonna come up the front side, blend to this guy just for a little bit, and then come back down the hem flange side. Okay. Now the way I have you do it kind of a backwards. Let me name this because I make you name it. This is the hem flange slab. All right. The trim sheet actually should be called hem flange slab trimmed. Should have copied the other one. Okay. So now we're going to make those blends. We're gonna make them with a radius of the material thickness. Right, I'm gonna start, I have you start in the back, so maybe I'll hide the front slab for a second. That's the main slab, that's gonna be the front of our door. So again, this is for the hem coming down the back. This is for that little tiny flat around the edge of the door. That goes back to what we were given a long time ago with a little bit of an offset. So we're gonna do a faceplate, I think. Because we could do a faceplate or we could do have you do a faceplate. So I'm gonna blend. Basically, I'm starting at the hem flange here. It's gonna come up from the hem flange. And I don't know if you can tell, but based on the finger pull there, it's coming up the hem flange, it's gonna round over this way, okay? So that really means it's gonna go that way. That's what makes it tricky. See, I show you a picture what it should look like when it's done, when you make this fillet. Right there, that's a little bit of the hem flange, that's the main flat on the top. Kinda look at the finger pull direction, see what I'm trying to get you to see there. Anyway, so it's gonna go to the left of that guy in this view, and it's gonna come down from that slab, so if I go to that, well actually, I don't know if I tell you this, but, yeah, I do say, select the reset arrow. Because remember, I got some weird settings on here. It's set the contact curve right now. I wanna do a regular face blend. Good habit, reset the face blend. So, I'm gonna start picking again. That one, going towards the outside. This one's gonna go inward or downward. And the radius is simply gonna be the fuel door thickness. Fuel door material thickness. I'll hit preview. Yep, coming up the flange, starting to go across the top. Okay, there's that one. I don't think, or do I? Probably. Oh yeah, that. Okay, so that's called hem flange surface. And again, it actually is a good thing to have these named, because if something goes wrong, you know which one you're supposed to click on by the name. And that does really represent the hem flange. We just gotta blend that to the front, the one that I have hidden right now, which is the back here, up here somewhere. Yeah, main slab design side right there. Okay. What I gotta do is take this little piece going across and then blend it to this. And it's the same, it's a face, I'll just read my instructions to make sure I didn't miss something. So I'm gonna take what I just finished, that guy, and you gotta picture this too. It's coming over the top, it's coming up the side, coming over the top, it's gonna go back down to that front surface. So it's actually going this way, so it's going to our left in that view. And then when we pick this main slab design side, that one actually is going back the other way. It looks really weird, but that's what it's doing. Okay, it's gonna go back across. It's already got the value in there. I'm gonna hit preview. There it is, and you see all that's left of that big cylinder is that little flat right there. Okay, so the first blend was coming up from the hinge this way, across to the flat, and then the flat coming back down to the front. And that was actually the last step. I'll hit okay. And of course I should rename this to fuel door. What did I tell you to do here? Fuel door? Yeah. I'll just rename it to fuel door. So the last thing in our part is a face blend called fuel door. Alright. So that's it. I'm gonna show you what I said I was gonna show you. Let me go to here. I'm gonna save everything I did. This is all kind of new. Actually, I saved it before I did my demo. But make the assembly active, the work part, and then if you hit save, it's gonna save everything inside here that needed to be saved. Okay. But then what I said you could do is, if you just wanna try it, open up your body side. I'll go to the assembly, open up the assembly for the body side. And then I'm gonna add, and you know another way to add is you can go here, you can copy a part. I think it still lets you do this in this version, and then paste it. Yeah, see, it added it. Of course, the problem with that is it doesn't have it filtered very well. You've got all that junk in there, but it's actually kind of quick. Remember this? If you make that active, remember you can go to View, Show and Hide everything, and then just go to the very last thing and show it. Oh, I hit the whole assembly too, sorry. Go back to the assembly and body side. There it is. Do that guy. I'm gonna do that again now. I'll got it. Let me go in here. believe me, it'll, you can hide feature groups too, maybe I gotta update to the end, maybe that's what I do. Hide that. Hide everything in the form, and then just show that. Maybe that'll work. There we go. So, see, it fits inside. Always seemed like kind of a, well, it does seem like kind of a big gap, right? But you know why? Because we're only on the design side. Realistically, we would add thickness to this, it would come out a little bit. We would add thickness to that, it would come out a little bit. So that, we're not really seeing the true width of the gap, but it does look like it's lined up pretty well, right? Because it all goes back, the reason that lines up with that, it all goes back to that center line we had a long time ago from the Class A people. Okay? Pretty simple? Maybe not real simple, but a lot of work, but we did most of those tools already quite a few times. It's just trying to visualize what I'm trying to tell you to do, that's the hard part. All right, I'll stop talking.
You wanna come home or something?
No, I'm tired. All right.